Okay, here goes an explanation of the answers to your final exam. There are two different tests, okay, that are kind of the same questions but just different orders. So if you did not have this one, you can look through it and see what the answers are to the questions and then just find those questions in your test. Question 1, or this question, in which of the following would the bond be covalent? So we have potassium, bromine, we have oxygen and oxygen, and we have magnesium and chlorine. So if the difference in electronegativity is, so electronegativity is less than 1.7, that's where we have a covalent bond. And if it is greater than, electronegativity is greater than 1.7, we would have an ionic bond. So if you look up the electronegativities and subtract them, you're going to get 0 for the O2, the oxygen molecule. That would be a covalent bond. Question 2, how many protons does an iron atom have? So we're going to find iron on the periodic table, and we see something that looks like 26 Fe 55.8. Okay, 55.8. So this is the atomic mass, or average atomic mass, chemical symbol, and atomic number. Okay. The atomic number is the number of protons that an atom has. The average atomic mass is the number of protons plus neutrons. So our answer for this is iron has 26 protons. Number 3, which of the following has, a positive charge? Has. There's only one, and that would be a proton. Neutrons are neutrally charged, electrons are negatively charged. An isotope just has a different number of neutrons, so it would have the same charge as the original atom, so the answer to that is proton. Number 4, how many neutrons would an atom of C14 have? So carbon looks like this, 6C and then 12.01. Yeah. All right. So again, average atomic mass, number of protons. So if it's carbon 14, it means this number here would be 14. Its atomic mass is 14. So 14 would be the number of protons plus neutrons that it has. So we have protons plus neutrons equals 14. If this looks like algebra, it kind of is, we'd subtract 6 to find that the number of neutrons is equal to 8. Okay, we would have 8 neutrons. 5, please find the molar mass of CuOH2. So what we do is we add up the masses of each of these atoms. Cu copper is a 63.5 plus, and we're going to have 2 of the OHs. So I'm going to add oxygen and hydrogen. Oxygen is a 15.9999 or 16.0. Hydrogen is a 1. Okay. And I think we end up with, what was this? 1734. Yeah, 97.5 grams per mole. Grams per mole. Okay. 2, question 6, or whatever question it is, how much does 4.2 moles of calcium nitrate weigh? Okay, CaNO32. So what we're going to do is we're going to add up the molar mass of all of that jibber jabber. Calcium is 40.07 plus, and we have 2 of these NO3s, and so nitrogen is a 14, and we have 3 oxygens, 3 times 16. Okay, and so after doing all that, we get something like 164 grams. All right, that is the molar mass for 1 mole of this. We then know that we have 4.2 moles, so we're going to have to multiply that by 4.2, which will give us, so we have 164 grams per mole, and that's times 4.2 moles. Okay, so the moles cancel out. We multiply these two numbers, and it's going to give us something really close to 689 grams. All right, next page. The Bohr model of a sodium atom would have how many energy levels? Looking at sodium on the periodic table, looks like 3. Number 8, the Lewis structure for a carbon atom would have how many dots around the C? So if we were drawing carbon and a Lewis structure, we could do like this or like this. In either case, it has 4 dots because it has 4 valence electrons. Number 9, the number of valence electrons in an atom, and this determines whether the atom wants to gain or lose electrons. For example, sodium, having only 1 valence electron, wants to lose that one, whereas chlorine, having 7 valence electrons, wants to gain one. 3 is closest to the electronegativity of which element? Oh, and I'm making this video lesson and I don't have the electronegativities in front of me, but I'm thinking that it was chlorine. So let's go with that, and hopefully I'm not wrong. You could just look at your electronegativity table. Pretty sure that was it. 11. What group of elements does not have electronegativities listed? So these are the elements way off on the right of the periodic table. These are the noble gases, and they don't have electronegativities listed because they are inert. They don't want to bond. They don't want electrons. They don't want to give away electrons. So they have a full octet, 8 valence electrons. They are happy. So that would be the noble gases. If I were an atom, I would want to be a noble gas. 12. Where are nonmetals most likely found on the periodic table? So nonmetals, those are off towards the right. The organic compounds like carbon, nitrogen, oxygen, fluorine, chlorine, those are nonmetals. 13. In the lab, we tried to make rock candy. What kind of solution was it? That was a supersaturated sugar solution. Okay, definitely not radioactive isotope. We'd be in trouble. 14. Electronegativity is a measure of, and this is the pull an atom has on electrons. Okay, so electronegativity measures how badly an atom wants an electron. The halogens, fluorine, chlorine, bromine, iodine, of course, being the ones that want electrons most. Okay. 15. What is the main difference between atoms and molecules? So, an atom is like this, whereas a molecule is something like this. All right. Molecules are made up of atoms. So that would be answer choice A. Difference between atoms and molecules is that molecules are made up of atoms. 16. Which of the following is a halogen? So you're looking at the periodic table, and it's the second, so not the far right row or column, but the one just to the left, and that would be chlorine, Cl. Okay, for 16. 17. Glucose is an example of a simple sugar. All right, if it's a bunch of glucose molecules bonded together, I'm not going to try to draw that. If it's a bunch of glucose molecules bonded together, it would be a complex carbohydrate, all right? But because it's just one, it's a simple sugar, and both of these are carbohydrates, which are different from proteins and fats. 18. Oh, and carbohydrates are used for energy, right? Right. And fat can be used for sort of slow burning energy, protein for rebuilding muscles, etc., etc. 18. Sodium and calcium are minerals necessary in our diet. Choose all below that we also need. So the 4 that I pointed out on the periodic table, if this is your periodic table, you're looking right over here. Again, if this is your periodic table, you're looking right over here. And that's Ca, Mg, Na, and K. Calcium, magnesium, sodium, potassium. We also need iron and a couple other things. But out of the list, you would choose potassium and magnesium. Okay, potassium K, magnesium Mg. Definitely not uranium or plutonium. Those are the radioactive elements used in nuclear bombs. They would be very harmful to you, especially if you ate them. 19. If you were reading nutritional information on food packaging, which hopefully you do, which of these would you most want to avoid? You don't want this. Okay, so there are a bunch of different kinds of fat. Polyunsaturated fat, that's the actual good stuff. You can find in like salmon and olive oil, canola oils, walnuts. And then there's bad kinds of fats, which are saturated fats and especially trans fats. So these are real processed. We would definitely want to avoid that. Ascorbic acid is vitamin C. Okay, if you don't have vitamin C, you'll get scurvy. That's what the sailors way back when used to do because the oranges wouldn't last. They would go rotten. So vitamin C and polyunsaturated fat are both good for us. Trans fat, however, no. And this is also described as hydrogenated oils, that kind of thing. Next. 20, which of these units is a measure of volume? So by volume, we don't mean cranking up the speakers on your stereo. This would be your stereo. Boom, boom, boom. No. By volume, we mean amount of stuff in something. So we've used graduated cylinders. The volume would measure how much there is. Meters is a measure of distance. Milliliters is a measure of volume. Kilograms would be mass or weight, and seconds would be time. So hopefully for this one, you chose milliliters. Thank you very much for listening. Correct your final. Mark a... you could put a smiley face if it's right. You could put an X if it's wrong. And then on the top, I'd like you to put something out of 20. Hopefully it's a 20 out of 20. But mark how many you got correct. Okay? And then turn that in. Thank you very much.